Thank you very much. Special thanks to the organizers for giving me this opportunity. Sorry, I'm recovering from my cough, so I hope my voice is okay. Maybe really quick, if you could open the topic, then I can quickly drop the slides before we start, or while I'm doing the introduction. So welcome everybody to this talk about lean-lsp-mcp. It is a collection of tools that agents can use to interact with Lean. So this is not an agent, but this is only the tools, so it works with many different agents. Okay. So the first slide is a bit of a motivation. Why do we need this? And the root of the problem is that models or LLMs kind of generate code without feedback often. So this is the use case where you go onto, let's say, ChatGPT on the website, the web interface, you type something in the chat. This model can obviously reply with Lean code or what it thinks is valid Lean code, but there's no built-in feedback in that. This is changing quite rapidly. We have more reasoning nowadays, we have more reinforcement learning, but still at the basis of it, there's no real feedback. On the other hand, a human user of Lean and a normal Lean programmer has a vast variety of tools available to them. For example, you might look at the info view to look at the goal state. You might run something in a command line. You're going to look at syntax highlighting, or you might use a web interface to look for a lemma that you're missing, something like Lean search. So lean-lsp-mcp is a toolbox that aims to provide these agents, these AI agents, with the same tools that we are kind of used to as normal Lean users. So what is meant by this? Okay, 1 second. I'm just going to upload the slides. That way you can follow right away. Here we go. Okay, so that's done. So what kind of tools can we expect in this toolbox? So currently this is 18 tools. This is not an exact number. We keep deprecating tools. We keep adding new tools. So this is very, very fluid at the moment. But what kind of categories do we have in there at the moment? So the biggest category of tools is those that obtain their information from the Lean language server. So this is questions like, okay, hover over this piece of Lean code and give me the documentation that comes up. So something that you might do daily, for example, in VS Code, we give this ability to an AI agent. Another category of tools is already what I mentioned, is this kind of library search. So these are typically questions, what is the API for XY in Mathlib? We have another set of tools to do code explorations. This means we're going to look at, okay, attempt these 5 snippets and give me the results for it. These are all things that you might do naturally, but it's much harder for an agent to perform. And finally, this is kind of a novel category, the performance profiling. What I meant there is more that this is going to have 1 or 2 more tools that are going to come up, and this is meant to optimize, or what is also called golfing. So once you have an existing proof, you might want to make it faster or shorter or more elegant. So we're also kind of striving to provide some metrics to the agent about that. Now, how can this toolbox typically be used by a mathematician, by a user? So usually in this plot, you can see that the green box, lean-lsp-mcp, is kind of a bridge between, for example, the language server and all these data providers on the right-hand side and the agent on the left-hand side. So you as a user would interact usually via a chat interface with an agent. And here an agent, for example, is Claude Code, or in VS Code, the agent mode that you can put in the chat. And this agent in the back, you are not going to control this interaction, is interacting with a model, typically a large language model. So in the case of Claude Code, for example, often this is a Sonnet 4.5 at the moment. But this agent also has a lot of tools available. So even if you don't use our toolbox, these agents nowadays are very powerful because, for example, they can read files on your computer, they can search things, they can run command line. Many of them have this feature, which is very powerful, as you can imagine. If you can run any command line, it's also quite dangerous, but they have all these tools available by the system. So these are often called system tools. And what lean-lsp-mcp does, it just adds more tools. So we have this toolbox, and these are lean-specific tools, and they will be used alongside this whole list of other tools that the agent already has available. That's also where the name comes from. The interaction between, so the way that lean-lsp-mcp, which is actually a tool, an MCP server, provides these tools is via the model context protocol. So that's the MCP part. This is a protocol by Anthropic. It's relatively new. It has its flaws. I'm not going to go into much detail, but the nice part is that it's quite standardized. So on the agent side, there's many different agents that can speak MCP, so to say. So for example, Claude Code, for example, your VS Code agent, or even if you have a fully open setup, like you're using open code as a harness and maybe DeepSeek as your model, they can talk just as well MCP. So this plugs into many of these agents. On the other hand, on the right-hand side, we can see that this MCP server is very dependent and would not be anything without all these amazing downstream data providers. So chief among them is the Lean language server, which is what we use to interact with Lean. So this is, for example, getting diagnostic messages. This is all the kind of things that you expect to see in your IDE. But we also have a set of external APIs that are accessed via the internet. So these are all the search tools. So like you could go on leansearch, I believe, .com, the agent can just call this API via this tool call. So big thanks to these providers as well. Plus, there is a whole bunch of tools that actually kind of use the command line. And we're running these in a separate process often. And these are things like the profiling I mentioned earlier, which is calling lean profile, for example. It extracts the theorem into a separate file with imports, runs lean profile, and then post-processes the result such that it's more token efficient. So with these LLMs, we always want to kind of minimize the context. They're stateless, these LLMs, and they need a lot of extra information. So if we can shrink down, if the agent doesn't have to read the whole file, but we can provide a summary, then this is an efficiency that has a direct influence on the tokens and therefore on the energy waste and so on. So what we're doing often is just post-processing and trying to find a minimal way of providing this information to the agent. So looking at this whole thing, so there's a whole diagram. We can see that lean-lsp-mcp really is kind of just a bridge of well annotated tools or methods between these agents and these amazing downstream providers. But as such, we can also kind of try to stay relevant as the agents change. So as we know, these models change very quickly. We have new models coming out all the time. They are changing the models they're actually running in the backend without us even noticing and so on, if there's peak time. So all of this changes rapidly, but the MCP interface hopefully provides us a relatively constant environment where we can keep providing these as the models upfront improve. So before I want to go into a bit more detail, I would like to spend or highlight 4 use cases on how this can be useful to you, or how this has been used, this toolbox, by different agents. The first 2 use cases. So, okay, first of all, this is a video. Can you guys see a currently paused video? Okay, great. I didn't dare to do a live demo also because we have different tools and so on. But what I want to show here in the first 2 cases, it's not the use case where you use this toolbox to do theorem proving. This is going to be later, but I think one of the key applications for these kind of agents is to actually use them as a pedagogical tool. or as a research assistant, and not to use them to do the actual work, but use them to summarize the work, which makes it easier for you to do the actual thinking or to get an overview. So this simple use case here, you can see we are in VS Code. On the left-hand side, we have a chat of VS Code. On the right-hand side, we have a file in Mathlib open. We can see that a theorem has been highlighted. This is just marked in the editor. I will pull your attention to the bottom left. We can see that this chat window is in agent mode. This is crucial, otherwise we don't have these tool uses. And we are using the GPT 5.2 model. And this is something I really like about the VS Code agent. It is how model agnostic it is. So you get to pick, and I often switch between models while working in VS Code with the agent, because some models just are better for some tools than the others. The prompt we want to know, so this use case is to help me profile and find out what were the hotspots in this function. So the prompt is profile this lemma using MCP tools, hover hotspots, then summarize as concisely as possible. So I'm going to play the video. As we start this prompt, we can see on the left-hand side, the agent is starting to think. It's starting to figure out how can I solve this problem for my user. Now it's currently, you can see here it's spinning, it's running a tool call from the MCP server, which actually profiles this function here, or its theorem. And it's currently thinking again, and it's going to do a few more tool calls to get the hover information. So for example, here we have goals. So this work came in very quick. Once it's warmed up, this is very quick. So we got goals, we got another goal. So this is essentially putting your cursor somewhere and looking at the info view to see what is the goal state. So it did it twice, and then it did hover information, and now it's going to give us the summary of this profiling of this function. We can see it has found some top slow lines, some minor problems, and so on. And if we scroll down now, here you can see it gave us a nice concise takeaway. I'm going to pause here of this profiling run. All of this would have been feasible for you to do manually. This is not the question here, but within a minute, we've gotten a concise summary of this situation. And it says the hotspot is this line 44. So it's this line with probably the simps, which consumes actually 73% of the time, which is 177 milliseconds. And we can also see the next hotspot suffices. This statement here, it's only at 32 milliseconds, so it's not as relevant. So if we want to do something, we should work on the hotspot. So this is a first use case where this agent, mainly this agent, but with the help of some of the tools from the MCP Toolbox, has solved or has given us a nice summary. In the next use case, and that's also the reason why I didn't want to do live, because there's now Claude Code, but we're doing essentially the same toolbox, but we have changed the agent to use Claude Code, and it uses obviously something like Sonnet from Anthropic in the back. And again, I'm using this as a research assistant. So today the prompt is, I want to learn about the API for traversals in simple graphs. Analyze using MCP tools, shortest summary of the basic structure, key operations, and theorems. So I've never looked at this, so I might want to get a summary. Again, we can watch the agent work. So it has done some search tool calls here. It has done some read tool calls. All of these are system tools. These are not in the toolbox. But now it's doing, and you can see here, it's doing some hover info tool calls. These are part of the lean-lsp-mcp toolbox. Some of them will actually fail because the agent tried to hover somewhere where there was no code, or it was an invalid coordinate, so this tool call fails, but they've all come back. It wanted to do some local search. This looks not very successful, and currently it's summarizing for us the traversals in simple graphs, and we're going to get our report in very soon. So again, this, I mean, if I had the time, I would love to just jump in and start reading code. But this summary is very efficient way to capture, to kind of look at this new information. And yes, so you could have asked the same prompt to your ChatGPT web interface, but here you're much more sure that you get the right information because this agent actually went and looked up the files. So you're not, and it looked up the files on your computer with your toolchain. So you're not dependent on the training being correct. And with the speed at which Lean and Mathlib develops, this is very useful to actually have real information. So the chances of hallucinations are, let's call it, lower than without feedback. So the next two use cases, I don't want to spend a lot of time on because this is not my work, but these are the two use cases to show theorem proving using this obvious use case for this toolbox. We can see by axiomatic X prover, this has been maybe October, maybe early November. They have built an agent in blue and it uses the MCP tools in yellow as expected. So their agent is quite sophisticated. They have achieved the 7th place as of this week on the Putnam bench, but there has been lots of development. So they were at a higher place before. The past months have been quite intense on this benchmark. Please refer to this paper and to the authors for any praise or deep questions. And similarly, the Numina lean agent, which I've literally just today made the slide in, this came out, I think, yesterday or day before yesterday. It is a open source agent with, I'll mention a bit more about that, but it's on the basis of lean-lsp-mcp as the interaction, but they added more tools to it. And also they added the bottom two tools in this toolbox, this one and this one, they're actually kind of tool calls, but they do their own reasoning and they do their own LLM calls, basically in this tool, wrapped up in this tool. So it's kind of a meta situation here. They have managed, and this is the first fully open or the first open source agent that you can reproduce just now, 12 out of 12 on the formal Putnam 2025 benchmark. They are using Claude Code as the intelligence. And here it says big open source agent, but you should keep in mind that at least the model or Claude Code is closed source. The model behind it is closed, as a closed model. And I'm also not sure currently if all of the search tools, the external search tools in the lean-lsp-mcp, I think not all of them are fully open sourced at this point. So this is an open source agent with caveats. But please refer to their paper and to their GitHub to look at the actual code on how this works. So I hope these 4 cases have shown you some of an overview of how this toolbox can be used. Here is the slide that shows all the tools. I'm not going to go into detail because it would take too much time, and I would like to encourage you just to look up the details on the README, where you can see that every tool is documented with this metadata. So we have a description, we have parameters, some of them have a description or a default value, and we're going to have an output schematic to kind of show the format or lean the type of the output to expect from this tool. I would specifically like to mention here the external search providers, which we're very grateful for. This is Lean Search, Lugal, Lean Finder, Lean State Search, and the Hammer premise. So this is a part of the Lean Hammer system. And these systems have gratefully provided us with a free API. So I would really encourage all the users, please stick to the rate limits that we have put in place. These rate limits have been agreed with all these providers. We are working on local tools to circumvent these rate limits. Moving on and looking at the time, I don't think I have time. I will skip this slide, but in any case, it would need a whole series of talks to talk about the Lean Language Server. It's such an amazing piece of software. It's really fascinating. I keep discovering new interesting facts about it. So I'm just going to skip it, but I would just like to thank the Lean FRO, I guess specifically Mark Huizinga, who has been working, they've been working tirelessly on the language server, on all these improvements. And the lean-lsp-mcp as a downstream consumer has really profited from this, and thus in turn also our users. So thank you a lot. And with that, I would like to skip that for another moment. Now, the next 2-3 slides, I want to talk about some of the challenges that you can expect when working with lean-lsp-mcp. So whenever we're working with agents or in general with large language models, we have the main challenge is the context. Because context is kind of what's filling up. So you have a context window, that and that many tokens. In this case, on the left-hand side, we can see a Claude code with only these lean-lsp-mcp and nothing else in it. And you run /context, you get this summary. You can see by even having nothing except this MCP, we're already using 23,000 out of 200,000 tokens. So this is about 12%. On line 4 here, we can see that the MCP, and this is only lean-lsp-mcp, is using 3,500 tokens. And this should be as small as possible, because as I mentioned before, tokens means wasting energy. It means we have a limited window, so it means also wasting kind of information that you can pack into this window. So we should make the tool descriptions as short as possible, but still prevent the agents from misusing the tool, because that would generate more tokens on top. So we have to find a balance. And also this has been extremely challenging to test, because essentially you can connect any type of agent and the behavior between Claude and VS Code might be very different because of the harness, because of the model, and so on. But there's something that you can do on your end if you're using this toolbox, and that's to disable useless tools. I very much support disabling these tools if they are not useful. And there's a variety of reasons why one or many, or most of the tools even, might not be useful to you. For example, your tool might be incompatible with the tool chain. So we're talking about this, this tool that does profiling. This is a relatively new version or a relatively new edition also for us. So it might not work with older lean versions. So you should disable it. Or your agent, your setup just keeps using a tool in the wrong way and you keep thinking, why are you doing this? Please, I would encourage you to turn it off. Or you're using something like open code, which already has language server support. So in that case, you can just turn off all the tools that have to do with language servers. You can still keep the external tools. You can still keep the lean-specific extensions to the language server, such as the goal state. But for example, hovering or anything like that, you just turn it off. In Claude Code, this has to be done via permissions. So you, at some point when you first get a tool call, it will ask you, do you want to do this? And this is in the settings file somewhere, and you need to deny the permissions to use that thing. In VS Code, you can simply click on this button here and you will get a nice dynamic drop down to kind of disable and enable different tools. So by disabling tools, you automatically will reduce the context. And maybe there's only a few that are useful to you or to your agent. The second challenge I'd like to talk about is picking the right model. And here I don't have an answer. A little bit of experimental data myself, but these models change very rapidly. There are benchmarks out there that go towards tool calling, how efficient and how often do you call tools. But tool calls, so you can see this graph on the bottom, I'm really sorry for the terribly small font. All of these 3 plots have a year. So we have November 24 till November 25. So this is a single year and they're all more or less aligned. And on the top, you can see that within a year, we went from nearly 0 to more than 50% reasoning tokens. So nowadays, across all of requests, and this is a very nice report by OpenRouter, we have more reasoning tokens than non-reasoning tokens, basically starting from 0. So this is mainly due to reinforcement learning or like thinking. Kind of often the model is thinking now, so those are reasoning tokens, but it's also due to, again, agentic workflows. At the same time, we've also seen a massive increase in tool calls from negligible to 15%. So agents do call more tools and they do like it more. So that's kind of in the favor of this toolbox. but which agents does what is very fragmented and changing very rapidly. So you're not going to get around some type of experimentation for your setup. I cannot guarantee you that one combination always works. So these are the main challenges. And the third challenge is not in the title here, but it is the fact that the language server is not the fastest way to interact with Lean programmatically. For example, there's related projects, the REPL, the read eval print loop, and the pantograph, which are actually written in Lean. They run a loop in Lean, and they're much faster. The advantage of the language server is that you get this rich semantic information, which is useful to us and to the agent, but the speed is not as fast. So if you want to do Monte Carlo graph search or something like that, I would encourage you to look at that. In fact, we have a PR that's about to be merged that uses also the REPL. So we will have an opt-in for the multi-attempt tool, where speed is kind of essential because we're starting from the same point and we're trying 5 or any number of snippets. And for this kind of use case, it is a single step in this kind of tree search. The REPL is fantastic. I'd like to mention Lean Interact and Kimina Server. Both of these are based on the REPL as an interaction method. And as I said, all of these would be faster than Lean Client. Lean Client is what we use underlying to connect to the language server. On the agentic side, there is another MCP. So you're not limited in the number of MCPs you connect. So you can connect a Lean Explorer MCP, which obviously works for leanexplorer.com. And if you're using Claude Code, then I would encourage you to have a look at the Lean Force skill by Cameron Freer, which works very well with lean-lsp-mcp. Because in this skill, you have more detailed descriptions of what the tools do. Again, this will use tokens, but the skills are handled a bit differently than the normal MCP tokens. And finally, these two projects, these are editor integrations. So obviously the VS Code extension and the NeoVim, those are always worth to look at. I look at them often to see how they handle different interactions with the language server. So with this, I'm getting towards the end, and I would like to mention a few future plans that we have on the radar. As with most smaller open source projects, we are just a group of volunteers, so we're not going to sign any binding agreements, but these should come out within the next months. We've had a good track record, especially the last few months. We've had a lot of releases, so I'm confident we can keep up the momentum for now. The first part we want to do is to add more support for these awesome new or these custom language server extensions that are in the Lean language server. So the Lean language server is essentially the standard protocol plus plus. So it's really amazing, and it provides so much more functionality that is very specific to Lean. So we are close to getting support for interacting with widgets, for rendering widgets So usually this has to first go into Lean client, and then we make the tool into the MCP. But this means that Lean client, you can actually use it separately from the MCP if you just want to interact with Python, with Lean using Python. Next, we want to focus on a set of local search tools. So we already have a somewhat crude but working lexical search tool, which is called local search, which uses a ripgrep. And the advantage is twofold. One is that with these tools, you can be sure again that you look at your own code and your own tool chain. Whereas these online search tools, you're dependent on them keeping it updated and then matching your version somehow. And also, they don't often include your own written code, right? So if you have a local search tool, it really fits to your project. And on the other hand, these local tools, they will be not under your terms. So if you use the external search tools, they are under the terms and conditions of the external search tool. So if you use lean search, that's lean search. I'm sorry, I can see that I'm going a bit too long. I'm going to be 2 more minutes since we have a break afterwards, and we started a little bit late. So bear with me, or feel free to go into the break already. Then this is the big one, and this is the one I want to spend a bit more time on. We want to add verification, a tool for verification, because as this toolbox really does enable AI to write more lean code, I feel like it's our responsibility to to give them the tools to actually verify. So we have to build a wall against the slop, essentially. So this is a problem for the community. I've seen this as a problem in other programming communities where they've become toxic because of the constant wave of just cheap projects rolling in and wrong projects. So I think it's important to have to give this tool to an agent that they can actually also work with this and try to make sure that the code is verified. We want to do this cross operating systems and using comparator as well as other kernels. So this needs to be thought out a bit more because not everything will be compatible with everything. Yes, and we'll keep doing maintenance. I'm not going to go into details. So with this, I would like to thank all the core contributors. We have actually managed 58 releases on the Python package index in the past, well, since 0.01 in March 25. So we've had a good track record. And specifically, I would like to thank Jesse, Elias, Alok, and Rex for their contribution to the MCP and the underlying Lean client. They've had all significant contributions in the past few months. I would like to, again, also in the name of our users, thank the providers of these external APIs. Thank you very much for running the hardware, running the service. And finally, the Lean FRO for the amazing language server, which I use daily, and many people actually use daily, and which has improved and changed so much in the past year. It's been an absolute pleasure. And generally the incredible ecosystem. So with this, if you want to try it yourself, feel free to look at, there's a lot of instructions on our GitHub. There is, if you're adventurous, you can just click this link and it will open a query in your VS Code that asks you whether you want to install this MCP, or if you use Claude Code, you can just paste this into the root, run this command in the root direct of your project. And with that, I am open for a few questions. Thank you very much for listening to me.